Yeah, welcome to one more session on this Mathematics 2. The topic is solution of a linear system. This one, how to compute the linear system by using the direct methods as well as by rank based methods. We are going to study in this. Now, if you see a problem, solve the system of linear equations x minus 4y plus 7z equal to 8, 3x plus 8y minus 2z equal to 6, 7x minus 8y equal plus 26z equals to 31, which is, if you observe clearly, the degree of variables x, y, z is 1 in each and every equation, which clearly indicates that it's a linear system or a system of linear equations, I can say that. Then that is expressed as ax is equal to b. Here the coefficients are 1, minus 4, 7, 3, 8, minus 2, 7, minus 8, 26. This is the coefficient matrix A. The variable matrix is our unknown matrix x, y, and z or z. This x, y, z equals to b. So here the constant matrix is 8, 6, and 31. Now I am writing the augmented matrix. As per the augmented matrix, first I need to dump the matrix as it is. Up to this, it is a coefficient matrix, and I appended the last column as constant matrix. This. Now here, my intention is this augmented matrix is supposed to reduce to upper triangular matrix. This is upper triangular matrix. Once it is converted to upper triangular matrix, then we need to check the rank. Rank of A is how much, and rank of C is how much. Then by comparing these two, I may get, then I need to compare this. So depend upon the comparison, we need to draw the conclusion. Conclusion, a solution exists or not. If it is exist, is it unique or infinitely many? That's what we need to check. Okay, let us back to the problem. By using this to reduce that echelon form, simply echelon form, to reduce that in the echelon form, I need to convert the elements below A11 to 0. That means this 3 is supposed to be 0 and 7 supposed to be 0. For that one, if I multiply this with the 3 and subtract from here, will be easy. So that's the reason R2 minus 3 R1 for the R2. Similarly, for this one, here is 7. So if I multiply this with 7 and subtract from here, we may get that. So R3 primes, R3 minus 7 R1. On simplification, I may get this. So elements below the first principal diagonal are 0. Next, I need to jump from first to second. Again, the same cinema. So upper triangular matrix means elements below the principal diagonal must be 0. So here, this supposed to be 0. This supposed to be 0. So for that one, what I wrote is plus 20. Here it's mine. Both are plus 20 only. Let me erase this. Then you may come to know this. Both are plus 20 only, so that clearly indicates that if I subtract directly, R3 minus R2 will get here. So R3 minus R2, we will get that all are 0 and this is minus 7. Now as for that, earlier I mixed. Now if I want, I can even split that. So this is a coefficient matrix. This is entire matrix is augmented matrix. So here if you see that rank of A is equal to, so number of non-zero rows are 2, rank of C is equal to number of non-zero rows are 3, number of non-zeros of 3. That clearly indicates that the both are not equal, then the system is said to be inconsistent. Yeah, how do you to say that inconsistent means? If you observe clearly this 0x plus 0y plus 0z equal to minus 7 means here 0 equal to minus 7. Is it possible real? No, it never possible. So that's the reason the solution is not exist in the case of inconsistent. Hope you understood this. Now this is the case for inconsistent. Suppose if I try another problem, solve the system of equations x plus y plus z equal to 6, x minus y plus 2z equal to 5, 2x minus 2y plus 3z equal to 7. As usual, the system of equations we can write here A as the coefficient matrix 1 1 1, this is first row, second row 1 minus 1 2, second row, third row 2 minus 2 3, this is, and the unknown matrix is x y z, then equal to constant matrix of 6 5 7, this was is given, then augmented matrix, these two I supposed to join here. So the if I join this 1 1 1 6, 1 minus 1 2 5, 2 minus 2 3 7. Now I need to compute its rank, converting this into upper triangular matrix. Upper triangular matrix. I need to convert this into upper triangular matrix. So for that one here, by using this, elements below the must be 0. So for that one, since both are same, so R2 primes R2 minus R1. That's what the operation. Here it is 2. So if I multiply this with 2 and subtract, then it is fine. So R3 primes R3 minus 2 R1. That's what. So in that first row is not altered. Second and third rows are altered because it's clearly specified which row I am altering that. Then control will jump from here to here. Here it is minus 2, here is minus 4. So here if it is a plus 4, if it is a plus 4, problem might be solved. So R3 I need to update R3 minus 2 R2, then only this will be updated, R3 will be updated based on that. Now if I see that clearly, this is the first principal diagonal elements below are 0, second principal diagonal elements below are 0, third principal diagonal no element is there, so we need left it here. So here I am getting a rank. Let me erase this. Now if I say this here, rank of A, up to this it is rank of A, rank of A is 3, and the whole is rank of up to this is rank of A, and the entire matrix is rank of C. So rank of A is equal to 3. Similarly, rank of C is also 3. That clearly indicates that both ranks are same, then the system is said to be consistent. The system is said to be consistent, and at the same time number of unknowns in X are also 3, then consistent with unique solution. I can write that. So to find the unique solution, we need to proceed back substitution method, means moving from the back in the case of upper triangular. So minus z equal to minus 3, then z equal to 3 here, then minus 2z minus 2y plus z equal to minus 1 plus 3, and simplification, and here x plus y plus z equal to x plus y plus z equal to 6 here. Now subtracting that, so substituting, we may get x is equal to 1, y equal to 2, z equal to 3. This is what is the guarantee that we did right or wrong? Simply substitute the solution in the given any one of the equation, you may get the same solution. I mean, the solution gets satisfied here. So in the place of this, if I substitute this any equation, substitute the solutions, we may get the 0. Yeah, so far we completed a linear system with inconsistency and a linear system with consistency with unique solution. Even in the consistency with infinitely many solutions of the same procedure, but in that one I need to assume some arbitrary constant. If you can able to complete that, you'll get it easily. See this, solve the system of equations x plus y plus z equals to 6, x plus 2y plus 3z equal to 14, x plus 4y plus 7z equal to 30. Now expressing that as a coefficient matrix, variable matrix and a constant matrix. Then from that augmented matrix, if you find the solution R2 primes R2 minus R1, R3 primes R3 minus R1, then here R3 primes in the first case up to this we'll get here 100, 113, 126, 6624. Then control will jump from here to here. So even in this elements below the principal diagonal. So here this 3 means here supposed to be 3. For that one I need to multiply with 3 and subtract here. So we'll do that. It's a 3R2 not 3R1 for your confirmation. Then if you see this rank of A is equal to rank of C, which is less than the number of unknowns. The number of unknowns are 3 here. That value is less than 3. So infinitely many solutions are possible. How can you say that? Because number of unknowns are 3. That makes a sense here. So since these two are equal, then consistent, the system is consistent, and the solutions we need to compute now. The same way I need to use the back substitution method only. So in the back substitution method, the last column is nothing, is empty. So moving to up, y plus 2z equals to 8. So y plus 2z equals to 8. Another one, x plus y plus z equal to 6. Now I may assume either x value or y value or z value, but if in this, to find the solutions I need to assume either x is equal to arbitrary constant or y equal to arbitrary constant, z equal to another arbitrary. I need to assume one, because the logic behind that one is number of unknowns. If number of unknowns greater than rank of the matrix, then what I can call is number of arbitrary constant to be assumed is arbitrary constants to be assumed is n minus r. Number of arbitrary constants to be assumed is n minus r. So here number of variables are 3. A rank, r is a rank is 2, which is 1. So means I need to assume one arbitrary constant. So let that arbitrary constant is considered as k. So if I substitute y plus 2k is equal to 8, then y equals to 8 minus 2k. Similarly, y equals to 8, this x plus y plus z equal to x plus y plus z equal to 6 in this one. So plugging these values here, x plus, in place of y I need to write to 8 minus 2k plus here c, simplification of that one here. After all simplification, I found here k x is equals to k minus 2. Similarly, I may compute the rest of that one. So x is equal to k minus 2, y is equal to 8 minus 2k, z equal to k. So z equal to k. So for the different values of k, we make a different solution. That indicates that infinitely many solutions are possible in the case of non-homogeneous solution here. Similarly, even this one also, 5x plus 3y plus 7z equal to 4, 3x plus 26y plus 2z equal to 9, and 7x plus 2y plus 10z equal to 5. Here same logic, augmented matrix, similar procedure. Whenever you want, you can pause the video and you can see this. Now let us see one more problem on this. So this here, solve the system of equations x plus 2y plus z equal to 3, 3x minus y plus 2z equal to 1, 2x minus 2y plus 3z equal to 2, x minus y plus z equal to minus 1. Let me try this for you here. Yeah. So in this one, this is the system. In this one, the coefficient matrix A is 1, 2, 1. Second equation 3 minus 1, 2. Third equation 2 minus 2, 3. Fourth equation 1 minus 1, 1. This is a coefficient matrix A, and unknown matrix X. Here X, Y and Z. Constant matrix 3, 1, 2, minus 1. Now from this, so far we discussed earlier problem. The shown problems are 3 variables, 3 conditions, but here 3 variables, 4 conditions. So even in this case also not a tough task, we can write easily. The augmented matrix is augmented matrix here 1, 2, 1, 3 minus 1, 2, 2 minus 2, 3, 1 minus 1, 1, 3, 1, 2 minus 1. So this is the augmented matrix. In this, what I need to do is, by using the first principal diagonal elements below must be 0. So I need to update R2. R2 I need to update as R2 based on R1. Similarly, R3 I need to update R3 based on again R1 only. R4 I need to update R4 based on R1 only. Now let me check one by one. R2 and R1. Here is 3. Here if I multiply R1 with 3 and then subtract 3 and then subtract, that will be 0. I'm not worrying about the rest of the element. Only the elements below the principal diagonal I'm worrying about that. So R3 minus R2. Here is 2. If I multiply the R1 with 2 and then subtract, we'll get it here. R4. Both are same. So simple subtraction only. So I make it here. Here R2, R3, R4 are updated. So R1 is not altered. 1, 2, 1, 3. These 3 positions we made wantedly zeros. So then here R2 minus 3 R1 minus 1 minus 6 minus 7 2 minus 3, because 1 times minus 3 minus 3, 2 times minus 3 is minus 5, 1 minus 9 minus 8, 1 minus 9 minus 8. So second row R2 minus 2 R1 minus 2 minus 4 minus 6. Here 3 minus 2 minus 3 minus 2 plus 1. Here 2 minus 6. 2 minus 6 will be minus 4. And R4 minus R1 minus 1 minus 2 minus 3. 1 minus 1 0. Minus 1 minus 3 minus 4. This is first step. Now my control will jump from here to here. From here to here I need to jump. Now here we'll be using this minus 7. I'm supposed to get rest of the elements are 0. So I need to update R3. I need to update R4. R3 updated here. R3 based on R2 only. R4 is updated. R4 based on R2 only. In this one R1 and R2 I haven't altered, so I need to write as it is. So 1, 2, 1, 3, 0, minus 7, minus 5, minus 8. Earlier we made these two are zeros, and now we made these two zeros. So only these four elements are supposed to compute. Before that, here is minus 7, here is minus 6. So since both are relatively prime, just multiply that one. So R3 primes, R3 means R7 R3. Because both are same signs, I supposed to subtract. So subtraction 7 6 R2, 7 R3, 7 R3 minus 6 R2. Similarly here, 3 sevens, R4 with 7 minus R2 with what I can write here, R2 with 3. So this is with 7, this with 3. On simplification, 7 R3 minus 6 R2. These two we made 0. 7 minus half minus plus 30. So I make it 29. 7, I repeat this. 7 here. This is a 6. So multiplying this with the 7, this with the 6 here. Okay, sorry here. Multiplying this with the 7 and but this with the 6. So minus 7 plus 6 5 30. Sorry, minus, oh, suppose if you get confused, simple logic, R3 is multiplying with 7, so 7 minus 28, R2 with the 6 R2, 6 R2, so we'll get here minus 30 6 R2, and here see, whenever if you are confusing this, you please write down that 7 R3 here. So R3 is 1 4, so 7 fours 7 minus 28. 6 R2, 6 5s 30, minus in minus plus, because here is a minus, here is minus, minus of minus plus, so plus 30, and minus into minus plus, 6 8 48. Now if I add this, because both are having the same sign here now, so it's 37 now. Earlier I wrote mistake. Now it's 48 minus plus 48 minus 28 will be 20. It's plus 20. Similarly, 7R4 minus 3R2. 7R4 means 7 times 0 0. 7 times minus 4 is minus 28, and 3R2 minus 15 minus of minus plus, I may get here minus of minus plus plus 24. Yeah, check once again. 0 0 times 7 7, 7 times 4 28, so minus, then R2 is, I need to multiply with the 3, minus of minus plus 15 minus of minus plus 24. Now if I simplify that, 15 here minus 4, that's what. Because here with the small mistake, entire went wrong, so that's the reason. You please be careful here. So once again, as for this, 7 times R3, all 7 times R3 means 7 minus 28 multiplied with the 7. Now 6 R2, 6 times, so already here is a minus, so minus of minus plus, 6 5s are 30, minus of minus plus, 6 8s are 48. So adding that 7 plus 30, 37, 28 minus 28 plus 48, so plus 20 I may get. Similarly, 7R4 minus 3R2, 7R4 minus 3R2, so 7 times 0 0 minus 28, and plus 3 times minus of minus plus 3 5s are 15, minus of minus plus 3 8s are 24. Then simplification here, 15 minus 4. Now a control is earlier first here, now here, now from here to here I supposed to check. Like this you need to check, no other options. Now based on the 37 I need to update R4. Here R4 primes, R4 with respect to R3 only. Again, and swap these coefficients here. Again swap these coefficients. So 15, here is a 15 R3, 37, 37 R4, and simplification. Okay, like this we may complete this. If I do that, 1 2 1 3 0 -7 -5 -8 0 0 -37 20, here 0 0. Now I made 0. Now what I can write here, see this, 37 here, both are having the same sign, means minus, change the sign here. The last one is 37 times R4, 37 times -4 minus 15 times 20. So what I may get here? Now we'll get here 37 times minus 4 will be minus 148, 15 times 20 will be 300. Together I may get 448, negative 448. Now how do we know that when we need to stop the problem? Simple. Below A1 on all elements should be 0. Then below A2 to all elements must be 0. Below A3 to all elements must be 0. Below A4, here it is augmented matrix. Since the last column is a constant matrix, I'm not worrying, only up to this. Now if I compare the up to this, it is a coefficient matrix. Up to this it is a coefficient matrix. Rank of A equals to 3. Together total rank of C, because this augmented matrix, here 4. Since both are not equal, I can write this as inconsistent. This one I can write as inconsistent. Another one more important concept, one more important problem on this concept is for what value of lambda and mu, the given system of equations x plus y plus z equal to 6, x plus 2y plus 3z equal to 10, x plus 2y plus lambda z equal to mu has 3 cases I need to explore. For what values of these? No solution, unique solution, infinitely many solutions. So far for the given system, what we'll do is we'll reduce the echelon, we'll reduce the augmented matrix to echelon form, then we'll figure out the rank, then comparing the rank of the coefficient matrix and the what do you call coefficient matrix and the augmented matrix. Based on that I may decide is it having a no solution or unique solution, infinitely many solution. But here some unknowns were given. So what happened to these values in these 3 cases, it was asked, but the situation will be the same. You need to identify the coefficient matrix and augmented matrix. So I read the augmented matrix is this, and reducing this to echelon form. So in that, this is the final matrix. Now here and here I need to check. Suppose no solution. No solution means what? Rank of A should not be equals to rank of A should not be equal to rank of C. So rank of A should not be equal to rank of C. But here rank of A and a rank of C, when it will be altered means in this, because up to second row they are same. So the only option is to me the third one, this lambda minus 3 equal to 0 and mu minus 10 not equal to 0. That only the case we can get it here. That only the case. So lambda minus 3 is not equal to 0 means lambda equal to 3, mu minus 10 is not equal to 0. In that case only that system does not have a solution. Now coming to the unique solution. Unique solution means this entire row at least one non-zero element must exist. Entire row at least one non-zero. Suppose that non-zero should not be this one. Suppose if it is 0, this is non-zero means it's meaningless. Just now you come across. So in that one, lambda minus 3 is not equal to 0. Then mu minus 10 may be 0, may not be 0. It doesn't make a difference because one non-zero element within the coefficient matrix is sufficient for me to decide the rank. So lambda minus 3 is not equal to 0 and mu can be any value. Infinite number of solution means rank of A and rank of C should be same, but which is less than the number of unknowns. In the given equation, the number of unknowns were x, y, z, 3. So it should be less than 3 means the only option is these both should be 0. So lambda minus 3 equal to 0 here, lambda minus 3 equal to 0 and mu minus 10 is equal to 0. That makes sense here. Lambda minus 3, lambda equal to 3, mu equal to 10. That's what. The rest of the concept we may discuss in next session.